1.7 transformations. So just like before and last year, hopefully you remember this. If it's outside my function, it does a vertical shift. And it does kind of what you think about it. If you add something to it, it's a vertical shift upwards. If you subtract something to it, it's a downward shift. Now, a horizontal shift, when we go left and right, is when it happens to be inside the function. All right? However, it's kind of opposite of what you may think. When you subtract out from the inside, it actually moves to the right. And when you add to the inside, it actually moves to the left. And here's why. When you set it equal to 0, you set x minus c equal to 0, you'd end up getting x is equal to a positive c. And so that means it does go right, a positive unit. All right? So outside moves up and down, kind of what you think. Inside, it moves left and right, and kind of opposite what you think, but you could set them equal to 0 if you ever have trouble. All right, so we're going to sketch graphs of these. We have a normal parent function of an x cubed, and now we're going to take some shifts to it. So my first shift I have is x cubed minus 1. What's it doing? It goes down 1. So this one just goes down 1. All right, so now we're going to start down 1, and then we're going to make our normal cubic function. All right. However, part B is the quantity of x plus 2 cubed plus 1. All right. And so this one is doing two things. What's it doing? What's one thing it's doing? It goes up 1, true that. And then it goes left 2. All right. It goes up 1 and left 2. All right, so left 2, up 1. So now we're starting kind of here. And then we have our cubic function going from there. However, one of my favorite singers is Michael Jackson. I'm talking about the man in the mirror. I'm asking him to change his ways. Reflections, and so it's kind of our symmetries going on here. If I change my y, okay, if I change my y right here, that's actually a reflection over the x-axis. If I change my x, that's actually a reflection on my y-axis. All right, so we've been talking about those symmetries. If it's a reflection over my y-axis, that's also known as a what? If it actually matches up. They're even functions. All right? So this is how you're going to be assessed on your quiz on Friday. All right? So I have a function x to the 4th power, and then I'm going to actually write out functions like this, and you're actually going to have to tell me what that function is. All right, what shifts of that function is happening and what that function is. So, if I have x to the 4th, well, how did I get from x to the 4th to this one? There's two things that happened. What two things happened here? Yeah?
You reflected.
I reflected. True that. What else did I do?
You went up 2.
I went up 2. So how can we write that?
G of x equals negative x plus 2.
Negative x to the 4th, and then plus 2. All right, so that's what that new function is. And then let's look at part B. So again, I'm going from x to the 4th, and this is doing something. What did it do first, before we do anything with our writing? What did it do? Somebody other than Elijah. What? It reflected. And it went what? And it went right. How many? 3. How do we do the right 3 thing? X minus 3 to the 4th. And then it actually reflected, so we have a negative out front. All right. Pretty good. What if we had that one? What did that one do? It reflected. What else did it do? It went up 2. What else did it do? It went right 2. So let's do all of those. So let's call this one, I don't know, j of x. That sounds great. So then reflected, so I need a negative out front, right? And then I need a quantity. And what's that quantity going to be here? X minus 2. Then I have it to the 4th power, and then what? Plus 2. All right? So now we're going to sketch these. Okay, now we're going to sketch these graphs here. So what's a normal square root thing? What's the normal parent function of a square root? Show me. There it is, right there. All right, so our normal parent, okay, just goes like that. True? All right. So this one, I have a negative square root x. What did it change? Did it change the x or did it change the y? It changed the y. So if it changes the y, it's actually a reflection over the what? The x-axis. All right? So if it changes y, it's a reflection over the x, so it's moving down like that. All right? And then let's do this one. What changed here? The x changed. So that one's a reflection over the y-axis. So that one goes that way. All right. I need a new color. Green. This one, what did this one do? It changed its what? Changed its y. All right. So it reflects over the what? The x-axis. And it moved which way? It moved left 2. All right, so it's going to move left 2, and it reflects over the which way? The x-axis. So it's going down like that. Let's see how we did. Congratulations. Let's talk about what those things are. If I have c in front, I have a constant in front of my function. Okay? If it's greater than 1, it stretches it. Okay? It's skinny. All right? That's the way I think about it. It's skinny. However, if it's between 0 and 1, I like to think of them as fat. Why is it not just less than 1? Why does it have to be between 0 and 1? What if it's a negative? Then what happens? It flips over the x-axis. All right, so that's why it has to be between 0 and 1. All right, the same thing works when it's inside. All right, if it's greater than 1, it's going to stretch vertically, which means it shrinks horizontally. All right, but it's skinny. It's skinny. Okay, if it's between 0 and 1, again, it's kind of wider. It's kind of fat. All right, I think of them as fat fractions. My parent is absolute value x. And so my normal slopes of absolute value x is what? What's my normal slopes? This slope is what? Say negative 1. Negative 1. This normal slope is 1. Well, now, if I have a 3 chilling on the outside, guess what my slopes are going to be now? 3 and negative 3. So I'm actually going up 3, and I'm going down 3. All right, so now I'm having a negative 3 and a positive 3. All right, you see how it's a bigger number than 1? What happened to it? It became what? Skinny. All right, that's the way I think of them. And then I have 1/3.
Excuse me, Mr. Flick?
All right, so this one I have is 1/3. And so what's this one going to do? This slope's going to be what? Fat. It's going to go wider. So now I'm going much wider, and so these slopes are going to be what? Negative 1/3 and 1/3. All right, those are works inside. Still works inside. So f of 2x, if I have this as my parent function up here, 2 minus x cubed, this 2x is going to become what? Fat or skinny? It's just going to be what? Skinny. All right? That's all I care about. And then this one, if I have f of 1/2 x, that's going to become what? That's going to become fatter. All right. And there it is. You have a quiz on Friday.